Now next 5 questions will be based on dimensional analysis, and this is the first question. And in this question they are saying that which of the following given equation are dimensionally consistent. So we have to see whether these equations are dimensionally consistent or not. So we're going to discuss the first one, which is x is equals to 1 over 2 a times t square. Now here you should know that x represents distance, a is acceleration, t is time. So now the dimension for distance, we know it is L, so we can write it as L is equals to, now 1 over 2, it has no dimension. Now a is acceleration, so dimension for acceleration is length over t square, that we discussed earlier also, multiplied with this is t square. Now t means time, so time will be, the dimension for time is t, so t square. Now here we see that this will be equal, so this t square and t square will cancel it out and we'll get L. Now here we see that the dimension of left side of the equation is equals to the right side. Therefore, we can say that the equation is dimensionally consistent. So this was the solution for the first case. Now next we can discuss the second case. So second equation we have t is equals to v over x. Now here this t is time, so dimension for time is t. V is velocity. Now the dimension for velocity we have length, that is L over time, divide with this x is distance, that means L, dimension for distance is L. So this L and L will cancel it out and we are left with 1 over t. Now here we see that the left side of the equation have dimension t and the right side of the equation have dimension 1 over t. Therefore this equation is not dimensionally consistent. So we can write that not dimensionally consistent. So this was the solution for the second case. Now next we're going to discuss the third equation. So the third equation we have t is equals to 2x divided with a to the power 1 over 2. Now let's see its dimension now. Now time, dimension of time is t is equals to, now 2 doesn't have any dimension, so leave it. Now x is distance, so distance is length, divide with, now the dimension for a, that is acceleration, is length over t square, and this is whole to the power 1 over 2. Now this length and length will cancel it out and we'll get, this is time t square whole to the power 1 over 2, which is equals to t. Therefore we see that the dimension to the left side of the equation is equals to the dimension of the right side. Therefore this we can conclude that this equation is dimensionally consistent. So this is dimensionally consistent.